Okay, yeah, so I'll start. So I want to talk about the impact of regional productivity changes in the U.S. economy. Joint work with Lorenzo Caliendo, Fernando Parro, and Daniel Pierre Sartre at the Richmond Fed. So the idea of the paper is to try to assess what's the impacts of these shocks when we have an economy in which different regions are heterogeneous and they can interact with each other. And I guess the basic kind of motivation is that when we think about fluctuations in the aggregate economy, there's a long tradition in macroeconomics that tries to or sees those fluctuations as a result of aggregate shocks. But then, more recently, not necessarily very recently, there's been a view that, these aggregate shocks are not really aggregate, or there's a few aggregate shocks, but many of these shocks are, in fact, disaggregated shocks. And so there's a series of papers that analyze, sectoral shocks and the impact of sectoral shocks on aggregate outcomes. So when you think about sectoral shocks, it's easy to come up with examples of what we have in mind, say like process or products innovations. What we want to do in this paper is we want to kind of add another dimension of disaggregation of these shocks, namely the level at which we're going to be looking at it. And then of course there can be combinations of sectoral and regional. Okay, so the idea is incorporate these shocks, and it's very natural to think about these shocks. These are things that are happening all the time, and we want to understand what's the, out of the aggregate fluctuation, what is the part that comes from these regional shocks or regional sectoral shocks, and in general, what are the forces that govern the impact of these regional shocks. And there's many reasons to believe that these are going to be important. One is that, when we look at the economic landscape, it is very heterogeneous. There's productivity varies quite a bit across states. And there's regional trade, there's local factors, there's migration, there's input-output linkages, etc. And all of those tell us that if one particular region receives a shock, other regions are going to be affected, and the elasticity of this shock is going to be mediated by all these things. And so what we don't have in the literature is a framework that allows us to understand what that elasticity is. If I shock California, or if California faces one of these shocks, what's the aggregate impact of such a shock? Now, one potential answer that could come out of this exercise is that it doesn't matter. It doesn't matter if California receives the shock or if Michigan receives the shock. As long as the shock is of a given size, the effect on aggregate outcomes is going to be the same. What I'm going to try to show you today is that that's far from the case. Where these shocks happen matters a lot. The elasticity of aggregate outcomes to local shocks varies dramatically depending on what the shock affects. And so, in order to show you that, I'm going to calibrate the model that I'm going to propose for the 50 US states using 26 traded and non-traded industries. And then I'm going to show you that I'm going to introduce different fundamental TFP shocks, and I'm going to show you that these elasticities are in fact different. And just to give you a preview, I guess, a 10% productivity change in New York State changes aggregate GDP in the US economy by 0.64%, while in a state of similar size, which is Florida, the same exact positive shock to Florida rather than New York is actually going to reduce GDP by 0.3%. Okay? So it's not only that the numbers are going to be different, even the sign can be different. Okay? So we're going to try to understand how can that be. Okay? So the first slide here, I'm really not going to spend too much time on it, but I guess the first thing that we need to do is I need to do is to convince you that in fact space is not uniform. right? I mean, that the distribution of economic activity is not uniform in space, sorry. That, in fact, there's a lot of heterogeneity, and therefore, because there's a lot of heterogeneity, it's natural to think that these shocks are going to have different effects. So, if we look at GDP and employment across states, it varies much more than the geographic size of the states. Also, the changes in GDP and employment vary a lot across states, and the reasons are these ones. Namely, there's a heterogeneity in changes in regional measured TFP, so the actual productivity in these different states changes differently, but it's also sectoral in the sense that the sectors are very different, distributed, are not uniformly distributed in space. So think about, oil is particularly concentrated in Texas, say, and these sectors receive very different shocks. So part of the heterogeneity that we see in productivities across regions comes from this heterogeneity in the location of industries across states, and the fact that different industries receive very different shocks in particular points in time. And then the final one is that there's local factors. So land, for example, is a local factor. The structures of a particular state are a local factor, and these local factors are gonna interact with these heterogeneous shocks to lead to differences in GDP and employment across states. Okay, so lots of heterogeneity in the economy, and in some sense it's a little bit surprising that even though we know that this heterogeneity is there, we don't have an exercise where we're trying to assess how this heterogeneity matters to calculate these aggregate elasticities to productivity shocks, okay? The other mechanism that is going to be very important here, and this is again just preliminary data, is intra-regional trade. The fact that states trade with each other, and because they trade with each other, shocks to a particular state are going to affect other states, and are not going to only affect other states, but they're going to affect these states in a geographically ordered way. That is, space is going to matter. And so one basic statistic is to look at interregional trade relative to international trade, and you can see how, at least in the US, that's about double. So it's a lot more important than international trade. So even though there's a lot of trade, what I'm going to show you at the end of the paper is that if you were to shut down that trade, that is, the transport costs are still quite important, that if I was to reduce those transport costs to zero, the economy would still gain a lot. So there's a lot of trade, but transport costs are still quite important. In particular, if you eliminate all these transport costs, GDP would about double in the US economy, or so the model is going to tell us. So lots of trade, but trade costs are still significant. And why is this important? Because then where you are matters, right? Where you are matters. California or Florida are different than Michigan, that is in the middle of the US. And the effect of these shocks is going to depend on that, okay? And so that's exactly the type of structure that we want to bring in, and we want to analyze. Long literature on this. Let me just say one thing about the literature, not really go over this in a lot of detail. I mean, the reason we can do that is because we're borrowing heavily from the international trade literature. So there's a quantitative international trade literature that started with Eaton and Kortum, and we're borrowing heavily from that literature, just apply that to regional economics and to these kind of more macro issues of how the shocks affect aggregate outcomes, but we're definitely using the type of structures that have evolved from that literature. Okay, so let me just spend 10 minutes or so in the basic structure of the model, and then I'll show you some results, and then I'll conclude. Okay? So the economy is going to consist of N regions, J sectors, and 2 factors. Eventually, I'm going to make those N regions the 50 US states, those J sectors the 26 sectors that I'm going to have. There's going to be 2 factors. This is important. There's labor that is going to be freely mobile across states. Okay, so when I shock, this is going to be important, of course, when I shock a state, that's going to, so for example, if I increase the productivity of a state, that's going to attract a lot of people to that state, okay? So there's going to be, people are going to move to that state, that's going to increase the GDP of that state, and it's going to empty out other states. And then there's the other factor, which is land and structures. And land and structures are going to assume, I'm going to assume that those are fixed at this local level. That is, if these are the land and structures of a given state, and they cannot move to some other state, but they can move across sectors. So different sectors can use this factor, but they cannot move across regions. And so already you can see one of the operating forces that is going to be there in the model, which is that if I shock a particular state, people are going to move into that state, but the other factor, which is this fixed land and structures, is not moving with labor, right? And so part of the effects are going to come from there, okay? So this is just the problem of an agent in region N, that is maximizing this Cobb-Douglas utility, and this is the budget constraint of the agent. So his income comes from labor, and then he receives a flow of rents from this fixed factor, okay? And so there's free mobility, as I said, so utility is equalized across these locations, where utility is just the income of these agents adjusted by a price index that is a price index specific to consumption in that region, okay? And the formula is that one, okay? So that's the agent, the consumption part of the agent. Now let's go to production. So production is going to be we're going to have many like Eaton and Quartum sectors, right? And so that's going to all happen at the intermediate good level. Okay, so in all trade is going to be in intermediate goods. So the way to think about it is all trade happens in intermediate goods. Different firms draw from the standard Frechet distribution productivity draws, and those productivities are then used to produce different varieties of these intermediate goods, just as in this class of models. And then these intermediate goods eventually are going to be assembled into final goods, and those final goods are what is consumed in the economy, okay? So there's these two stages, if you will. But all the action, in some sense, and certainly all the trade in the model is happening at this intermediate good level. So there's two things that are important here. The first one is, there's going to be an idiosyncratic productivity draw, this ZJN, that depends on the sector and the industry, coming from a Frechet distribution with some parameter, just as in Eaton and Quartum. And then, and this is the one I do want you to remember, there's this TJN, which is the level of where this distribution is in a particular sector and in a particular region, okay? And this is this is what I'm going to be calling fundamental productivity in a sector region, okay? This T is what I'm going to be shocking. When I talk about a shock to productivity, I'm talking about a shock to this thing, okay? To this TJ. Okay, so you're drawing productivities from your standard Frechet, but the level where the Frechet is depends on this TJN. Okay, and so this is your production function. So output is equal to your idiosyncratic productivity. Then this term here in bracket is your value added, and gamma nj is your value added share. And then you use materials of final goods in all the different, in all the other sectors. Okay, so that's the way you produce intermediate goods. Notice one thing that it's important here. So value added, how do you produce your value added? There's workers, the L, and there's this H, which is this non-traded factor, and then I have this T multiplying here. That's the fundamental productivity that we were just talking about. But this is within this bracket, right? Inside the bracket. So the share of value added applies to this. That is, your productivity affects your value added, not your gross production. And this is important when you see the numbers, okay? It's a model in which if I shock everything in the economy, that is, if I shock all the productivity of all states in all sectors by a certain amount, GDP is going to go up by exactly that amount. Okay? So I'm constructing a model that has that feature. In order to have that feature, you need that T inside. Okay? Otherwise, you're going to have like bogus amplification effects that only come from the fact that you have it outside. Okay? Okay, and then you have your standard thing. So you have like the cost or the input bundle that you use to produce a particular good is given by this, where R is the price of the non-traded goods, the non-traded factor, W is the wage, and then you have the price of all these final goods. And then and under competition, as in Eaton and Corton, prices of a particular variety are going to be just the minimum of where you can buy this thing, which is the average cost of buying it, which is this term here, adjusted by the transport cost, these kappa and i's, which are the transport costs of sending one of these intermediate goods from region N to region I, okay? And then I have the other layer, which is less interesting, which is just once all these intermediate goods reach a particular region, you assemble them into a final good, okay? And the way you do that assembly is through this CES function. There's no action there. It's just an aggregator of those intermediate goods. But those final goods are the ones that are used as materials and are used for consumption, okay? So shares of consumption and shares in production can vary because this function is CES, even though the utility function is Cobb-Douglas, for example, right? Okay, so that's, and then, the rest of the model is just standard thing, markets clear, etc. Okay, so let me not describe it too much more. So now I'm going to spend a couple of minutes telling you what is the impact in this model that I just showed you of a change in this fundamental productivity. Okay? And so the first thing is, what would be the impact of a change in fundamental productivity on measured TFP in a particular industry, particular region? Namely, what's the impact on A, which is going to be measured productivity, of a change in T, which is fundamental productivity? Why is fundamental productivity and measured productivity different? Well, one is that measured productivity is going to come from the actual goods, the actual final goods produced, and so the gamma is going to affect this T, and the other is that that there's trade, and I'm using this trade. We're drawing from a particular distribution, and how much I draw from that particular distribution, that is how concentrated the production of a particular intermediate good is in my region, is going to affect my average productivity. Okay? So this measured productivity, so this is the change, the percentage change in measured productivity in a particular region, is going to be a particular function of the fundamental shock in productivity, which is this object. And so it's a function that is just take the shock, raise it to the gamma, that's the value added share that we talked about, and the second part is just divided by the change in the fraction of goods that this region produces, so the set of intermediate goods in industry J that this region produces for itself. Okay? And so what is the logic here? The logic is, well, when I see measured productivity, and this is well known in these trade models, when I see measured productivity, what I'm actually seeing is some average of all these draws that the firms are taking. But now think about that suddenly California becomes more productive. If California becomes more productive, there's more draws. But California is producing more goods, it's going to produce more goods. If California produces more goods, the marginal firm in California is going to become worse, right? And so because the marginal firm in California becomes worse, the actual measured productivity in California is not as good. The opposite happens in Michigan, say, if I show California. In Michigan, now Michigan is going to be producing less goods. Because Michigan produces less goods, it draws less, so the firms that actually get to produce are more selected, and so average productivity goes up. Average measured productivity goes up. Okay? So all these effects on measured productivity are going to come, or what I'm going to call the effects on TFP, are going to come from one of these two effects. Either the value-added share, or this selection effect. Okay? The fact that that changes in fundamental productivity are going to change the selection of where these goods are produced, and regions that end up producing more are going to look less productive, and regions that end up producing less are going to look more productive. Okay? So that's that effect. Okay? So you have the direct effect, and then this indirect effect through this share. That's important. It's in some sense, think about it as it's like an insurance mechanism, right? I shock a region, right? And then productivity in that region doesn't go up by that much, because the marginal firm that comes in is worse than the average. While in regions that don't receive the shock, the marginal firm that comes in now is better, right, than the average before, and so productivity goes up. Okay, so that's the effect on TFP. Now let's look at the effect on GDP. The effect on GDP is going to be the effect on TFP that we just talked about, plus two more effects. The first effect is just the fact that people are going to go into that, there's going to be a change in the number of people producing in that region, so there's going to be migration as a result of the shock, right? But there's another effect, which is the effect that I was alluding to before, which is that if a lot of people come to a particular region, that strains the resources in that region. Remember, this talk of immobile factors or local factors is given, so when lots of people come in, right, you're facing decreasing returns from the fact that these factors are fixed. And so the wage to input bundle price ratio, if there's no intermediate goods, this would be the wage to rental ratio, right, is moving against you when you when you receive a lot of migration. Okay? And so that again reduces the impact of the shock, and already in some sense hints how can you have negative effects. You can have negative effects because lots of people come to your state, they gain of course, but they stress resources a lot in your state while they're leaving other states where there's lots of these resources, right? And now there's not enough people, or there's less people out there to use those resources, okay? And so that imbalance can in principle lead, or in some extreme cases, can lead to these negative changes, okay? How am I doing with time?
15 minutes.
Okay. And then you have you can do, you know, welfare, your standard welfare calculation, which is going to be given by this, which is just your TFP effect that I told you about, and then this effect that we just talked about, but it's aggregated according to, in some sense, the utility function, right? So it's aggregated through the alphas, it's not aggregated through the production price indexes, and so utility actually is always going to go up. Just for those of you that know this literature, if you know the Costino, Arcolakis, Costino, and Rodriguez-Clare paper, for example, in their framework, that's like a one-sector model without migration, then the change in utility is just going to be the change in TFP, is what I discussed as the change in TFP. Here you have these other effects because you have migration. Okay? Good. So now we're going to calibrate this model. I'm not going to spend a lot of time talking about it. We're going to do everything in changes, so that we're going to use the Deckel, Eaton, and Kortum type of trick, where we're just going to look at what's the effect of changes in fundamental productivity on the change. So how is the economy going to change as a result of changes in productivity? I'm not going to actually calculate the level variables. Why not? Because in order to calculate the level variables, I need to identify fundamental productivity, and I'm not doing that. So I'm going to avoid identifying fundamental productivity. What I'm going to do is I'm going to introduce the shock, the change in fundamental productivity, and that's going to tell, and the model is going to tell me how the economy changes as a result of that change. Okay, so that leads to a big system. It's a big numerical exercise, big system of equations that one has to solve, etc. Lots of parameters, and there's, the paper spends a lot of time trying to explain how we calibrate all of these parameters. This is relatively standard in the literature. I mean, in some sense, the more interesting data that we use is the commodity flow survey. Commodity flow survey tells you all trades between states of the US in all these industries that we're using. And so the model, we're going to calibrate the model in a way that matches these trade flows exactly. Okay, so from there we're getting all the transport costs, for example, across states. Okay. So here is one of the results. So this is a map of the US economy, of course. And then these numbers here that you see, hope you can see them. What they are is or what they mean is the following. If I shock California, well, California is hard to see. If I shock Texas with a 10% shock to all industries in Texas, so just general 10% fundamental productivity shock to Texas, measured TFP in Texas goes up by 0.26%. Right? So now part of that, of course, part of the change in Texas is the result just that, you know, Texas is not the whole economy, and so the size of Texas matters because when I shock Texas, right, I'm shocking a particular share of the US economy, right? So part of it is that, and so you can see what part of it is that, which is about 0.7, so Texas amounts to about 8% of the US economy, so that would give you about 8%. Now, the reason this is not 8%, but is not 0.8%, but 0.26%, is that there is input-output linkages in the economy, and there is trade in the economy. And because of trade, there is this selection effect that is operating in this economy, okay? So you go from about 8%, an 8% shock to the US economy, and the effect of that shock is about a 2.6%, okay? So the effect, the shock is reduced quite a bit, even in measured TFP, right? Because of these two forces, the input-output linkages and the trade linkages, okay? Now, let's go to real GDP. So we can, now, same shock, okay? And remember, these numbers are what's the effect on the aggregate economy of a shock to that particular state. These are not local effects, right? These are effects of a local shock on the aggregate economy, okay? Now, if I look at GDP, now, then you get this effect that I was highlighting at the beginning of the talk, which is that GDP in some states grows quite a bit as a result of the shock. So in Texas, for example, by 0.552, or in New York, which was the example that I was using before, 0.64%, while in Florida, it goes down by 0.3%. And in some other states, it goes down too. So what is it about these states that is doing this? Well, what's happening, or the effect, the key effect is that when these states are receiving a shock, people are moving into these states, okay? And when they move to these states, the whole structure of the economy changes. And so where the state is and who the neighbors of the states are and where are the industries in which these states are producing matter a lot to measure this elasticity. Okay? And in particular, in the case of Florida, which is kind of an extreme case relative to the rest, I mean, there's other negative numbers, but I mean, this is the key negative number, or the most extreme number, is the fact that Florida is very isolated, and so, and the states that are next to Florida are not very productive states, and so when Florida gets this big shock, these other states cannot benefit that much, or cannot benefit that much by producing, say, intermediate inputs for the things that Florida produces, and Florida is kind of isolated from everyone else, so lots of people move to Florida. That is, in order to take advantage of the shock, you actually have to go there. You cannot take advantage of the shock being somewhere else, right? Which trade in general helps you do, right? You can take advantage to a shock in California if you are in Nevada, right? By just producing stuff that the industries in California use, right? And because you're right there and there's a lot of land close to it, right? Nevada benefits. But in Florida, that happens less than in other states. It's all relative statements, of course. And so you can have this type of effects. But I mean, don't focus too much on the negative. The negative is just illustrating the forces that are at play in the big heterogeneity that you see in these different effects. Now, when we look at welfare, on the other hand, welfare is much more uniform across space. So welfare, if I shock Florida, aggregate welfare goes up as it goes up in New York, and in fact goes up by pretty much the same amount. Okay? So now let me dig a little bit deeper. I know you have a question, but let me dig a little bit deeper into this example. So let me take the example of California, and then I'm going to show you the example of Florida. Okay? So now the numbers mean something else. Now I'm actually going to shock California, and I'm showing you the effects on the different states. That is, these are the regional effects of a shock to California. Okay? So these are not the aggregate effects anymore. And so I shock California, right? These numbers are hard to see, but I'm shocking California by 10%. Actual measured TFP only goes up by 4. And you can see how TFP, measured TFP, also goes up in all these other regions. And that's that selection effect that I was talking about. That's the only effect operating there. Right? The reason productivity is growing in states that are not receiving the shock is just the selection effect. Now, the selection effect is not very large. As you can see, these numbers are, in general, somewhat small. Now, this is, let's look at employment first. Now, employment grows in California by 25% or so. So you shock California, it's a big shock, of course, and it sucks people out of everywhere else. Okay, so it attracts a lot of people, and so that what happens, it empties out other regions. Okay, so in particular, one example of that is Illinois. So Illinois is a state that happens to have a lot of local factors. And so when you take people out of Illinois, the wage to rental ratio increases a lot. Okay? So the disparities, if you will, in wage to rental ratios increase a lot, and that's not good for the economy. Or that's not good for GDP in the economy. Not for welfare, but it's just GDP. Right? So welfare, GDP suffers from that. And so Illinois, in fact, if GDP in Illinois reduces or goes down by 2.67% in that example. Okay? Yeah. Now, let's look at Florida, which is the kind of example in the other direction. So again, you shock Florida. Now TFP in Florida goes up by about 3-point-something%. I cannot quite read it. 3-point-something%. So same kind of order of magnitude than in California. All these other locations tend to win. This is not exactly right because, of course, some locations may lose because, for example, if Florida buys a lot of oil from Texas, now there's more entry in Texas, right? And so productivity in Texas can actually go down, right? And so that effect is also operating here in the background. But in general, these other states are going to get are going to have positive effects in TFP. But what's interesting about Florida is kind of what I was pointing out before, which is it really kind of increases much more the number of people. Migration into Florida is much larger for the same size of the shock than to California. So California population increases by 25% with the shock. Florida population increases by about 32%. So more people go to Florida, even though Florida is a smaller state. And so, of course, output per worker in Florida is still going up, right? But it's going down everywhere else, right? So all these other states are losing from people moving out. Florida is gaining, but the gain in GDP from Florida doesn't compensate the losses from other states, and so GDP in the aggregate goes down in that example. Okay, so it's not a TFP effect; it's really a migration effect combined with these local factors. Okay, so you can see the importance of these local factors and kind of the role that they're playing. They're certainly playing a big role with these extreme numbers. So then we can start thinking about, well, how are we measuring these local factors, and are we sure that we're doing a good job in measuring these local factors and the effects of these local factors, okay? So the way we're doing it, just to give you like a preview of that, is just we're looking at income, we're taking wages out, right? And the rest of income, right, is equipment, structures, and land, and we're taking the part that is structures and land as the part of these non-traded goods. Now, is that exactly non-traded, etc., or local? I mean, like, there's some debate there. That's what we're doing. And I mean, these extreme cases, I mean, if we were to change these numbers, may change a little bit, but the big heterogeneity that we're getting as a result of that is not changing. I mean, there's other type of examples that you can do, of course. You can also shock sectors. So this is an example of the transportation equipment, so the car industry, a shock to the car industry, and how, kind of, what's the regional effect of a shock to the car industry, which, by the way, interestingly enough, empties out the Midwest and certainly Michigan in terms of employment. You would think that the effect would be the other way around, that Michigan would benefit a lot from a shock to the car industry, but actually no, because, you know, cars are material inputs in a lot of industries, so so now that productivity went up, you want to produce cars next to other industries, and so Michigan actually suffers, not a lot, but suffers a little bit from it. Even though, of course, the change in measured DFP in Michigan is large because they are large in that industry. Okay, 2 minutes maybe. No. Okay, so one last exercise that I want to do is remember I told you. So we can take this model, and of course, once you have the model, you can do a bunch of counterfactuals with the model. One counterfactual you can do is change the transport costs, as I was alluding at the beginning, and so what we do in this exercise is take reduce trade costs in the U.S. economy, and then we break it down in the part that is related to distance and the part that is related to other barriers. So we just have some reduced form match with distance. And so just to break it down so you can see the importance of these costs in the US economy, and that's the 125 number that I was citing at the beginning. If you were to eliminate this, the economy grows a lot. So what this is telling you is where things are matters a lot. Right? Where things are matters a lot. If I eliminate this, because big chunk of these gains comes from the fact that you can reallocate economic activity in a way that takes better advantage of where productivity is. Okay, so you know the exercise. We think this shows or illustrates the importance of these regional changes. We think it's fundamental if you want to understand the elasticity to particular shocks to bring in the regional dimension. It's big, it's rich, and it matters a lot. Of course, this is just an agenda that we're starting on this. So there's many things to do. One important one is to, so far we're just introducing shocks of a particular size. You can also use the model. I mean, you're going to need a little bit more structure to identify the actual changes in productivity, which is something that we want to do in the future. The other thing is you can think, well, why doesn't Florida just build more houses, right? Now, it cannot really increase the amount of land, but it can build more houses, or it can increase the stock of local capital, and that would definitely help. And so local factor accumulation is an issue, certainly in the long run. Or at least for some 5% of the 15% that is these local factors. And then we don't have regional trade imbalances, and that's something that one wants to think about. Okay, thanks. Huh?
Questions both at the end?
Well, yeah, let's take the questions at the end.
Okay, so since Daniel isn't here, we're just making up on the spot what we want to do. The agreement was just now that we'll take questions at the end. So I'm not sure whom to thank. No one's here to thank. Thank you for coming, and I'm happy to be here and present this work. Now, is Control N or what is it? Control? Yeah. Okay. So this is joint work with Elhanan Helpman, Oleg Itzkoki, and Steve Redding, two of them at Princeton, one at Harvard. And I've wondered why I was asked to present this work rather than more recent work on comparative advantage, which might have tied in with Esteban's presentation. Now I think I understand. A lot of the invited sessions had to do with inequality. And the notion that came through in some of the discussions, but I think in academics is by far not as prominent as, say, in the public discourse is it the case that as economies globalize, as they grow, TFP changes, that inequality necessarily increases alongside. I know that in academia we don't have a settled view on this, but the public seems to be obsessed that that seems to be the case. And this paper clearly has something, has a lot to say on this. In fact, it helps quantify at what stages of, say, globalization or development more broadly the relationship has one sign and at what stage is the other. So concretely, there's a long series of work on inequality in trade and how they relate. The old classic trade theory had a very clear view coming from the Heck-Jolene general equilibrium model, by which inequality would increase in one region while it goes down in the other as factor earnings converge towards global relative factor earnings. And that's not been borne out in the data. The series of studies since at least the 1980s or so shows that inequality, if anything, increased both in the South, broadly speaking, and the North over the last 2 decades. So it's inconsistent with that view. So many have then just concluded that trade cannot be the culprit or cannot be closely associated with inequality because it gives the wrong predictions to at least half the world. Now, that view I think can be questioned now with rigor. There's a new nexus between trade and inequality coming through effects of trade on employer earnings and the shared rents that employers share with their workers. The reason why revenues are dispersed have to do with a series of empirical findings and theoretical work that show that within sectors, the dispersion of revenues across firms and the participation in exporting across firms varies strongly. So it's not the sector that determines how globalized you are, but really within the sector, the distribution of sizes across firms and capability across firms. And if some of those rents and revenues are shared with workers, then you have an immediate nexus to inequality because as revenue becomes more dispersed within a sector, so do wages within the sector. And that is basically what this paper is all about. Now, I will show you that most of the empirical work is based on, or all of it is based now on linked employee data for Brazil to give concrete evidence on the mechanism. And in the talk today, I should have said this talk rather than this paper, I will emphasize a bit more the qualitative insights on the empirical side. I'll spend probably about half the talk on that, just to show you the support for this new mechanism. Then I will briefly discuss how one can put this into a structural model, and I will emphasize the empirical difficulties in implementing it. So the exercise is essentially quantifying how strongly trade or globalization more broadly impacts on inequality in wage earnings. There's a long list of work on the more recent framework that makes rigorous the idea how firms participate in trade and the heterogeneity of that trade participation in revenues inside sectors is a paper by Marc Andreas that I'm sure many of you are familiar with. And on that builds a series of modeling frameworks that ask how then revenues and rents across firms are shared with workers, either because there are frictions in the labor market or because deliberately, and there's some efficiency of fair wage considerations that make employers share rents with workers through wages. The evidence on the fact that there is a size wage premium, that is old. In fact, I care to go back in the literature and check where it probably first appeared. I believe that the very first employer-employee data set that at least I could track is by Henry Moore, a US labor economist he traveled to Europe and he found for northern Italian female textiles workers in the early 20th century a first employer-employee data set, and he documented actually all the things we're still talking about, namely that large employers have the better work conditions. They pay higher wages, have shorter work weeks, and all the other goodies. So there's no surprise here. We've also seen that larger firms are more frequently exporters, or exporters are more frequently large. So there's also no surprise then that exporters pay higher wages. But what we do is we make those insights rigorous, and we show a path to quantifying how strongly globalization contributes to inequality change, and showing, in fact, that that is not a monotonic relationship. So it can go both ways, and in Brazil in particular, we might just be at the cusp where the sign changes. So what we use is the universe of formal sector workers, not just a sample of textile workers in northern Italy. So we can track the economy-wide effect. We have exports transactions data for the firms. We restrict ourselves to firms with 5 or more workers so that we have a good measure of, say, within inequality as well. You need at least 2 workers to compute the variance. We concentrate on the log wage. That's mostly driven by the fact that much of the wage estimation is based on the Mincer approach, which uses the log wage, so we just think it's the natural variable to consider. And taking logs means that we're becoming insensitive to units, which is helpful, especially in times of high inflation. And we then compute, essentially, the variance of the log wage as our main inequality measure, or we take the standard deviation to be precise. So it's a very straightforward kind of data work that I think is designed so that we can connect to existing work. So as I said, I want to spend about the early half of the talk on 4 big facts. I've lumped what's in the paper, facts 1 and 2 into one. Just to emphasize why it appears tantamount that we depart from this view that sectors or sector occupations determine inequality. It's really within where we have to look. So the first exercise is a very simple one. We just take the total variance of wages in the economy in any year T in Brazil, and we divide it up, or split it up, I should say, decompose it, into a within component, and L here, that's the cell within which we computed, and the between component. So the variance has this nice feature that it is linearly decomposable that way. The within component simply measures the square deviations of any individual worker's log wage from the L-wide, that is the sector occupation-wide cell. And the between measure then measures how strongly these cell-specific average log wages differ from the economy-wide one. Yeah, so that's the between measure. So we see how much variation happens within sector occupations and how much between. I skipped a bit of evidence here, and I obviously need to say what our definitions of sectors and occupations are. The Brazilian linked employer-employee data that we use offer about 15 manufacturing sectors for the whole period and a finer grid in later years. And as to occupations, they offer up to 350 finely defined ones, but since most of the literature always talks about 5 big ones, from professionals all the way to unskilled blue collar, we mostly base our analysis on 5 occupation cells and 15 industries. But I'll show you that we are not sensitive to that kind of definition. And then I'll come to that in a second. So the bulk of variation, that is the bulk of dispersion in wages between workers, is within sector occupations. So here, if you just do sectors or just do occupations, we'd be in the 80% range. If we combine them, so we form smaller cells, exactly we get about 60 cells here. In each year, 70% are within sector occupations. Yeah? Now, you might wonder that our definition of the sectors or the occupations is too crude, and just mechanically, the finer you make the cells, obviously the numbers will go down, but we never go really below a half. So in the late period, where we have more than 250 sectors and more than 350 occupations, which makes for about 60,000 cells or so, even then, only 50% is between. That is, most of the variation happens within these even very narrowly defined sector occupation cells. And sector occupation cells, if you wish, they are the empirical counterpart to actual lean trade theory. If you look at changes, that is, how does inequality change over time, the change within cells actually is decreasing inequality. So all the increase that the Brazilian economy observed during those years, it comes from within sector occupation, changes in inequality over time. So the bulk of the cross-sectional variation is within sector occupations, and the change is only there. So that's the first couple of facts. Then you wonder, well, what then, can we say anything more systematic about the within sector dispersion of wages? So what explains it then? If everything's within, or the bulk is within, it cannot be sector occupation characteristics. Does the employer perhaps capture it? So how much of the within sector occupation dispersion is explained by dispersion across employers? And for that, the answer is, again, it's about half. So if the within sector occupation dispersion is not idiosyncratic to some worker characteristics we can't see. Half of it is because of firm characteristics, because they are at this particular employer. So the firm dispersion explains about half of the within sector occupation dispersion. In levels, in say 94, but that's true for most years. If you look at changes again, then everything is between employers. Yeah? So within sector occupations, that's where all the dispersion sits and all the change happens. And there, within sector occupation, it's the employer changes, that is, wage level changes at the employers, that explain everything. Yeah, so the within change, in fact, declines over this period. So that suggests it's not idiosyncratic worker characteristics that drive the sector occupation inequality. It's really systematic and systematically related to their employers. So that's the big third fact. And then last you can ask, well, what is it about the employer? How much is the export status matter? How much is it just the size of the employer, or maybe other characteristics? So we just design a very simple horse race in a regression. We put the log wage on the left-hand side and regress it on the employment size at the firm, H, the number of employees, and an indicator whether or not the firm is an exporter or not. And in such a regression, H and I are obviously correlated, so this is not a clean decomposition of the variance in Z. You have the variance in Z is dependent on the variance in H, the variance in I, the variance in the residual, where all the worker unobservables go, and a covariance between H and I, because exporters tend to be larger, so we know that two regresses are actually positively related. So that's our decomposition for this very last question. How much does export status matter as a firm characteristic to explain what we found so far, namely that the bulk of inequality is within sector occupations, and that's mostly related to employer characteristics. So, and the answer is export status is not a smash hit in the cross-section. We know that from many, many similar regressions. But if you ask about change in inequality, that is predominantly explained by changes in export status. And firm employment actually happens to go the other way. That is the largest, initially largest and highest wage firms downsize in Brazil over that period. Now you can ask whether that is particular to the period or to the country, and I don't have a definitive answer on that, but it is for sure encouraging for our kind of nexus that in this context, export status is what explains everything. So the bulk of the inequality is within sector occupations, something classic trade theory can't talk to. It's across employers, so it's not about idiosyncratic labor market shocks or idiosyncratic worker characteristics. And that the main employer characteristic that seems to drive wage inequality in Brazil over that period is the export participation of the employer. So that is, I think, the set of facts that motivate our theory, and I did want to spend a bit extra time on this, just to be clear that we are not adding some marginal explanation here. It seems the bulk of the explanation is actually here. And from prior research until the, say, 1990s, we know that most labor economists tended to conclude trade can't matter for inequality because sector occupations don't vary enough. And so we now say, sure, that's right. Sector occupation level trade theory doesn't matter for inequality explanations. But firm level explanations probably have a good good point to make. So that's all I wanted to say about the basic facts that motivate or justify this approach. What I'll now do is I will briefly talk about a theory written down by my 3 co-authors initially, and how we extend it to match the data. And then I will talk about how we quantify that model and what we then can learn from about the non-trivial interactions between globalization and inequality. So to do that, I'll explain the model briefly, and then I'll show you that the model does really well in the data, even though it's basically the most parsimonious one we could write down. And then I come to that counterfactual. How much does globalization matter for inequality? So the Mellitz model has a hardwired, innate firm capability at its core. And that is one of the main shocks in our model as well. Typically, that's thought of as a productivity shock. The firm has a marginal cost shock. If productivity is high, marginal cost is low, of course. It could be thought of as any kind of demand-side shock as well. It's not well defined. But what you should think of it is it's an innate firm capability, and the firm just draws this capability and then lives with it for at least the year in which we estimate it. Now, if you have a model with only that characteristic, which was the initial model that Helpman and Skokie and Redding have published in Econometric in 2010, that fails to match tremendously salient features in the data. One, the Mellitz model predicts that the worst exporter, the least productive, least capable exporter, still pays a strictly higher wage and has a strictly higher employment than the very best non-exporter. Yeah, so that's the prediction in this model. It's a clean cutoff. Everyone below the cutoff is strictly worse in any outcome measure than everyone above the cutoff. And that's clearly violated in the data. You see large overlap in employment between exporters and non-exporters. So this, if you plot the supports between exporters and non-exporters, there's not a clean cutoff. There's huge overlap. The largest non-exporters are way larger than the smallest exporters. So that one we deal with by introducing a fixed entry shock. So firms just get some lucky draw as to whether they can become exporters or not, and we can then have an overlap of any sort between those two supports. The other fact that you'll soon see when I finally estimate and simulate the model is that the employment distribution is distinct from the wage distribution. If anything, the employment distribution looks a lot like a Pareto distribution, as we've seen, or a lot more in prior work, and the wage distribution looks a lot like a log normal distribution. So they certainly don't, you can't see, surely cannot overlay each on top of the other. So that means we need to separate, we need to have another shock that separates the wage outcome from the employment outcome. If it were just for one productivity shock, that wouldn't be enough. And what we introduce is a screening shock. In the Helpman and Skokie-Redding framework, the labor market friction that gives rise to employer-specific wages is a screening cost, and so we give the firms a shock which they draw. So at this point, I should make a little observation, I guess, as to what the broader family of models is. We are not claiming that the Helpman and Skokie framework is the ultimate one to estimate this. It's probably a representative of a broad family of models that can deliver very similar estimation models to the one I'll shortly present. But what we found in trying to model the right shock structure to get the data right, not even within the Helpman model, or within the Helpman and Skokie-Redding model, not every kind of shock combination delivers the right data results, or matches the data in the right way. So a screening shock is one thing that works. For example, what would not work is a shock to the bargaining weight in the model, how much workers gain out of the bargaining process with their employer. So that suggests that although there's a broad family of models that would give rise to similar results and similar estimation models, not every model we know fits it for sure. There's some data and theory work that needs to be combined to get the right structure down. Now, how does the model work? Essentially, the firms screen a set of applicants who show up at the doorstep, out of them they hire a fraction, a number big H, that's the employment that we will then observe in the data, and they screen for the ability of these workers. It's a very simple test that tells the firm whether or not a worker is above or below a certain ability threshold. If the workers below, don't hire the applicant. If the workers above, hire the guy. And obviously, if you screen more to a tougher standard, then you'll raise the average ability of the workforce. A lot like the mechanism we just saw with average productivity in a sector and region, I guess. If you cut the bad end, then you raise the average of those who make it in. And the production function is pretty standard. The average ability, however, that interacts with the total employment, so there's a productivity boost from having a higher skilled labor force. And the employment actually is not, they're decreasing returns to scale in employment for some technical reasons that I don't want to spend much time on. So that's the production structure. I will now just tell you very briefly what the results are and then how to put it to an estimation model. So the firms then, given their cost shocks, they choose whether or not to enter the export market. They choose the screening threshold to which they want to screen their applicants, and they end up with a certain level of employment and a certain level of productivity of their workers. The revenue that they generate, that's just a concave function of the output that they produce. That parameter there is a beta, and I just put it here because it shows up shortly again. The model then predicts that because there's a discrete fixed cost of exporting that exporters need to cover with their revenues, as you jump from non-export status to export status, there's a discrete jump in all the outcome variables, in employment and wages and revenues. And then the prior model in Econometric has shown how you can use the Stolen-Zwiebel framework of individual bargaining between a single worker and the employer to figure out how the revenues will be distributed between the firm and the workers. And the answer is it'll be a fixed ratio that depends on how concave revenue is in output, the beta, and on how concave output is in employment, the gamma. And you get a share between 0 and 1 of revenues that will go to the wage bill. And if you divide by the number of workers, you get the wage per worker. So to be clear, there's one wage per firm. That's what the model says. So the model is completely silent on worker heterogeneity. In our data work, we need to get rid of that heterogeneity. So what we do is we run Mincer regressions that condition on anything that the workers observed about. And we tease out from each cross-section the the firm fixed effect in the cross-sectional Mincer regression. And that's then the wage that we observe and we use in our data work. So that makes the data comparable to the model, so to say, or beats the data into the model's shape. The estimation model is a pretty straightforward one if you look at it in logs. The log employment is just a linear function of whether or not the firm's an exporter, plus some constant and some error. The log wage is a function of the export status and then a different kind of residual. And then there is export participation decision. The firm is an exporter if its idiosyncratic export shock exceeds some minimum fixed cost level. That model, that kind of estimation model comes out of the Helpman-Skokie framework under the assumptions that we made. As I said, it takes some work to get the model to present you with these kind of estimation equations, and it's not clear that all models would give you that, but it's also probably the case that many other models would give you a similar framework. So on this, I want to make two observations. One is the theory predicts that the premium on exporting should be strictly bigger than 0, or weakly bigger than 0. But there is a novel feature here that's not that clear from, say, a baseline Mellitz model. How can you generate a wage premium in this model? We know in the data since at least 1911 that the mu W is positive. Well, one is just the mu W is positive in the data, or in the data generating process. Another possibility is that the shock on being a lucky exporter, a high J draw, correlates with any of the errors, say with U or V. If that's a positive correlation, then even for a 0 mu, you can get a wage premium observed at exporters. If it always is the case that the guys who are lucky to export also are lucky in the screening process to find the really good workers, then they will exhibit high wages, W, but the exporter premium itself is actually 0. So that is a task for the data, or the model actually, or the estimator, to sort out where the premium comes from. Does it come from this natural mu, or does it come from a correlation between the exporting shock and the wage shock, the screening shock? And the data are very happy to tell it apart for the employment equation. The data have a difficulty to nail it for the wage equation. So we've gone back and gone through, a bunch of theory restrictions that naturally come out of this model. And one basically implies that theta and eta should be orthogonal. That then pins down the estimator. So there is a kind of, there are some estimation difficulties that I at least want to mention. And they come from this new selection effect. So the mu W could call that simply the exporter premium. And the relation here, you could think of that as a kind of selection effect. Only the very best exporters are also very good at screening, so you get a wage premium from that. So there are two channels through which you can observe a wage premium. I think that's an important lesson just from the theory, but it's hard to estimate. How well do we do? Well, stunningly, for this very simple structure, we basically nail all moments except for one that I'll point out here. So the data say that the standard deviation in employment is higher than the model says once we estimate it. But other than that, we've basically nailed all moments. At the firm side, the standard deviation in employment and the log wages, the correlation between the two, the share of exporters. And if you look at the worker side, instead of looking at firm level outcomes, you can look at worker level outcomes in our data. We've nailed most moments as well. There, the only thing is that the highest earning employees, actually the model predicts a bit more inequality than the data. But in essence, we're there. So there's also a way to graphically show that. The blue stuff is always the model, the blue stuff is always the data. The red stuff is always the model. For the log wages at the firm level, we've basically nailed the distribution, even if we discern between non-exporters here and exporters. The exporters, as you can see, have a higher average wage, but the support overlaps strongly. So that's why we need the fixed exporting shock. In terms of employment, we are doing okay, I guess. We are not quite capturing the bad low tail. That looks a little more like an extreme value distribution, whereas our estimator says we're log normal. For at the worker level, a very similar picture. We nailed the data quite good, I think, but there are discrepancies. Now, before I go and try to convince you that the model also explains Brazil's inequality, there's one issue I need to get rid of. I showed you in the simple early regression that exporting status explains maybe a couple of % of overall wage dispersion. Yeah? Whereas the residual of unobserved worker characteristics explain 90%. So how in the world are we going to generate, with this simple model, inequality change in Brazil as it happened? The answer is, it's not because we don't replicate the data. So if you run the very simple OLS regression on the firm wage on employment and export status, we get exactly the same coefficients as we get in the data. So we run the model, we simulate the model, then we run that regression like in the data, and it's the same result. So the model, in other words, doesn't explain much of the cross-section and inequality at any moment in time. That's the fact. Most of it is in the worker residual. But what we capture is the systematic change over time in exporter participation. So we don't do well in any cross-section if you just think of the R squared. But if you go over time and look, where does the change come from? And there the answer is, it comes from export participation. Yeah? So in the cross-section, not good, the R squared. But once you do the dynamics, you get pretty close. And let me show you in the last 5 minutes that I got indicated the two counterfactual exercises you can now run. So first, let me actually start with this guy. The standard transport cost that we've just seen in Esteban's counterfactual exercise, we can also perform that here. So let's bring down the implied transport cost level that our estimated model suggests, and now ask if we vary that so that no firm at all is an exporter, 0%, that is infinite transport cost, all the way down to negligible transport costs so that almost 100% of firms are exporters. So we bring tau, the transport cost, from infinity to nothing. How does implied inequality vary in Brazil? If all the firms are non-exporters, then there is no inequality. It's just the baseline level of inequality given by the worker residual. And we standardize that to 1 here. If every firm is an exporter, then there's again no dispersion within a sector occupation because all the firms are the same, they're all exporters. So then again, we're back at baseline inequality for all the workers in the economy, which is given by their residual unobservables. But as we move from 0 to 100, a fraction of firms is exporting and a fraction is not exporting. So that induces dispersion between the high wage paying exporters and the low wage paying non-exporters. And as you move, you naturally come to a peak and then you go back down to 1. So that you get that kind of peak, that's a theory result from the prior Econometric paper. But the important question you can now ask, where are we close to that peak? Are we past the peak? And in terms of transfer costs for Brazil, the answer is in 94, for which we now estimate the model for many data reasons. We are not quite at the peak yet, so further globalization in Brazil will actually be associated with an additional increase in inequality by about 0.3%. But from then on, inequality will decline. So there's this non-monotonic relationship. The inequality goes up as the economy globalizes from no exporter to some exporters, and then the inequality will drop again. And back down to the baseline level of residual worker inequality that you just can't get rid of. If you ask the same question, but now you vary the fixed export cost, that affects only one margin, namely whether or not you export. The transport cost, that affects a lot of margins. It affects the premium you pay and affects of whether or not you're exporting at all. So the tau gives you varying the tau gives you a different answer because more margins are affected. If you just vary the fixed cost of entry into export markets, that affects only the entry margin. And there, Brazil is actually at the peak in 94. So from then on, any, say, further WTO negotiations that bring down product standards, harmonize safety requirements and whatnot, all the kinds of fixed costs of exporting, Brazil is there. Anything further will just bring down inequality. Yeah. So let me conclude and I'll take the question. There's more to do. The one thing I want to mention that we have not time to show is you can ask how diverse are the exporters actually. Some just ship to Argentina, some ship to the US, Argentina, and many other places, and some ship to half the world. If you look also in the strong dispersion in exporters among themselves, some are just marginal exporters, some are top-notch exporters, then the change in inequality is way stronger. So then the model predicts even more of Brazil's inequality change and actually starts to over-predict it, partly. So what I've shown you that new theories in trade can give you a new nexus between inequality and globalization. The action is within sectors and occupations in terms of wage inequality, and they're mostly explained by export status and a structural framework, very simple, we think, very basic, I should say, nails the moments in the data and gives you a very clear prediction as to how far Brazil is from suffering further increases in inequality from additional globalization, or maybe now a double benefit, if you wish, reducing inequality and increasing the gains from trade. Okay, so I'll stop here because I promised Esteban that we take joint questions, but you want to ask them first and I?
Maybe this may be a joint question. So, part of the presentation saying that some of the previous models were able to explain half of the increase in inequality, the comparative advantage models, the heterogeneity models. Now, I'm wondering whether this is for Brazil, and this period you study, there was a big increase in openness. But on the other hand, I know that in the UK and the US, inequality has also increased a lot. And correct me if I'm wrong, I mean, was there a big increase in trade with China, maybe?
Yeah, so I mean, it depends on how you want to measure it. As Esteban showed us, U.S. is a closed country in terms of exports plus imports per GDP.
Yeah.
But partly because so much of the gains from trade are probably exploited by interregional trade. So is the U.S. an open economy? Well, by tariff levels, yes. By de facto foreign trade, no.
But then you have to say that there was a change in transport costs within the U.S. in the last 20 years or something to explain.
Yeah, or fixed export costs. So they're still coming down. Transport costs are coming down. If you think of David Hamilton's work. So to be really clear, we've not estimated this for the United States. I'm not aiming to. And I can't tell you whether the United States is to the left or the right of the peak. But just as a matter of principle, every single country could be to the left of the peak. There's nothing that tells us that shouldn't be the case. And so it's a matter of empirics to find out where we stand. So all countries could jointly move up in inequality. Yeah. So if you, just to the question what we add, Hexual-Lean says in the south the wage gap declines, in the north it widens. We show that it's not necessarily the case in line with empirical findings. There are extensions of the Hexual-Lean model, say the offshoring model by Feenstra and Hansen, that then already say, well, with intermediate goods trade, you get an inequality increase everywhere. What this adds is a qualification. Yes, maybe, but it really depends on where the economy stands at the moment, whether you get the positive or negative sign. So it's a richer model in that sense, and certainly can reproduce prior findings, but also more. Esteban doesn't want a question.
I was going to ask you, so from your example on how in Florida, the first example of when we had a positive shock in Texas, and then GDP went down in Florida, and your explanation was that, well, Florida is a bit isolated, so it doesn't gain much from trade or cheaper inputs, but people will still go out. So it seems that what's going to matter is how easy it is to move people versus how easy it is to move goods. And it seems that the model has the discipline on how hard it is to move goods, but you kind of have like an extreme position on labor is freely mobile. So do you think that's something worth taking more seriously, quantitatively? Or?
I agree. I guess our view is that when you trade goods, you're shipping them all the time. And so you're paying this cost every time you're shipping the good. And so to the extent that this is a model, a static model, this, you're paying this transport cost every period. Well, if you move people, they move once and that's it. And so at the end of the day, these costs are going to be relatively small. That is, it's not about, there's some frictions, and these frictions, mobility frictions may be important in the short run, but eventually these people do reallocate, and then once they pay that, then they are there. While if you're producing in a different place than where you're consuming, you have to ship these goods every period. You have to keep shipping them. And so that's I guess, the reason why this framework, in particular of ours, but I think there's a whole tradition of these frameworks, has taken the view that this free mobility assumption is okay, even if you have transport costs. But obviously, the big issue is, in some sense, we take this view also because this is what we can do, right? If once you start bringing mobility costs and so on, the models become very complicated, and so. Given that, again, did you only move once and so on, maybe all that complication doesn't seem to be worth the effort that would imply. So here, in some sense, when you think about these frameworks, I think one interesting thing to think about, and then I'll finish with this, is you really have to choose your battles. right? I mean, in the sense that these are big frameworks already, right? With lots of bells and whistles, lots of equations, lots of data that goes into these calculations and many effects. And so you have to choose your battles and emphasize particular dimensions, and you cannot just bring everything in. And so I guess we made that choice.
You're getting traction from this model from having some mobile factor and some region-specific factors, but what you call it is almost immaterial. You could say that capital is mobile and subsume labor as being stuck where they live. Sure. Then the empirics think. Yeah.
Well, I mean, we're linking it to particular facts, so it's not quite, I mean, that's not quite right. I mean, here capital is mobile because capital, I mean, is not just some sort of abstract thing, but it's actually the machines, right? And you're trading the machines, and these are the material inputs that you're actually trading. So capital can move, but can move by paying these transport costs that you have to pay, right? I mean, so that you can import cars, if you're going to use cars as material inputs, or you can import machines, but it costs you to import these machines, right?
You know what I mean? I mean, capital in terms of finance.
Now you can have labor that is, you know, equipped labor in some sense. And to the extent that you think about equipped labor, you know, you can move labor also by changing the equipment that this labor holds. I mean, that is the capital that but I mean, I didn't really go into a lot of detail into this, but you see a lot of changes in employment across states in the US, right? So that's, I guess, the other answer. There's a lot of changes in employment in the US. So, you know, whatever the costs are, somehow, you know, these costs are being paid, and, you know, these changes are happening quite a bit. While when you look at land, right, which is the 10% in some sense that amounts for most of our immobile factor, well, land is land, right? So that's fixed. That's fixed by, and then there's a 5%, which is structures that it's more up for grabs, right? That is, how exactly do you take structures, and how do you build those structures, and where you want to kind of bring in the construction sector, etc. But this is really kind of a smaller part, and most of these effects are not that affected by this. Okay, I think people are coming for something else.